Okay, Assalamualaikum and good afternoon. Okay, today we are going to continue with our next lecture, Chapter 9 or Module 8 in our CCNA Switching Routing and Wireless Essential, SLAAC and DHCP version 6. Okay, last week we have taken a look what is a DHCP, and we have configured DHCP version 4, which is create DHCP server for IPv4. In the meantime, we also configure our router interface with the DHCP configuration, which means that interface acts as a client. Okay, for today, we are going to focus on IPv6. That's by the name itself, DHCP version 6. And in order to provide a service, a DHCP service, we also have another service similar to DHCP. We call as a SLAAC, SLAAC. This is for IPv6. Okay, there are several topics in this chapter. First, IPv6 Global Unicast Address or GUA. Okay, compared to IPv4, we have a public IP and private IP, which means public IP is a routable to the internet. It can be routed in the internet, but private IP is not routable, unroutable in the internet. We cannot route private IP in the internet, which means public IP must be unique because it must be present as a one entity only with one IP because it's routable in the internet. Okay, that's for IPv4. But for IPv6, we have a global unicast address. And for your information, IPv6 we doesn't need private IP. So there is no private IP in IPv6. After that, we are taking a look what is a SLAAC and what is a DHCP. So there is a different service that offered by SLAAC and DHCP, even though both of them are trying to give thing that will be auto configuration. Remember, DHCP is purposely to auto configure a device with a IP automatically. So the same thing happened in IPv6. We have a SLAAC and DHCP version 6. And the last topic is a configure DHCP version 6 server. Okay, first topic 8.1 IPv6 GUA assignment. So what is a GUA? Global Unicast Address. Compare to IPv4, we have a public IP. But for IPv6, we call as a global unicast address. And every IPv6 address that we can configure to interface, it can be a global unicast address. But for your information, maybe you already know, we already done that in some time, or our IP configuration for IPv6, we must configure for the global unicast address and the link locker. But maybe I forgot to tell you, link locker, if we do not configure, in our router, they will automatically create for you one. Same for the client, for the PC. Okay, to configure IPv6 global unicast address in your Cisco device, you just need to give the command IPv6 space address space and then their IPv6 address. Let's say 2001 column, DB8 column, ACAD column 1, double column 10. I hope you already know what is a double column. Then we follow by slash prefix length. We must put a slash, and prefix length is the subnet size, the size of the subnet. The size of your network. So for IPv6, we are using the IP length with a 128 bits. So how many bits that you reserve for your network ID? So in this case, let's say 64. So we put 64. So our host, our network actually have a size of 64. It's not this 64. Actually, the size of the network actually the other part of the LAN. So we are already fit 64 for the network LAN, network prefix. So we have another 64 for the host. Because IPv6 we are using 128 bit compared to IPv4. For IPv4, maybe you already use /24. So for the /24, which means you already prefix to the first 24 bit for the network ID. and the last 8 bit for the host ID. So same thing with the IPv6. Compared to IPv4, we can easily type IPv4 address, but IPv6, it come in with a very long binary number, so easily converted into hexadecimal, but it still need a lot of effort in order to memorize and in order to retype that number. Sometimes you might have mistype and create an error, and it's all time consuming in order to type a very long number, and if there is an error you need to refit and so on. So it's good if we have a feature that can automatically configure their IP address. So like in this Windows 10 configuration, you just click for the obtain IPv6 address automatically. So in order to obtain IPv6 address automatically, we must have another service enabled. It can be SLAAC or DHCP version 6. So this is what happens when you do IP config or you view the configuration on your PC. So this is on your Windows PC. So you can see link local IPv6 address has been set up automatically. Whenever you enable IPv6, of course it's enabled by default on current Windows operating system, you should see there is some number starting with the FE80 column or double column followed by a trail of hexadecimal number. And at the end there is a percent command, percent symbol followed by some number. This is just to represent this link local are within this local area network. So that's a link local address. Link local address, the scope are within one subnet, one network only. So we can use the same link local IP address in the other network because that beyond our scope, and they doesn't care about our local link local IP address, and we don't care about their link local address. So how can we configure global unicast address automatically? So there are several ways. First, by using a stateless, either by using SLAAC or SLAAC with DHCP server, or we can use a stateful, which is everything are configured through DHCP server. So there are two states now, stateless and stateful. What is a stateless? Stateless, which means we doesn't care or we do not depend on other setting. They are isolated inside their own room only. So they are configured by their own. That's a stateless. But we have a option for stateless with a DHCP server. Why we have a stateless with DHCP server if we already have a stateful with a DHCP server? Okay, to explain that, I would like to go to DHCP server. I mean stateful DHCP server first. Okay, for a stateful DHCP server, everything will be configured by the server. So server will keep track what's your IP address and so on. But for the stateless, I mean for SLAAC with the DHCP server, stateless with the DHCP server, DHCP server will not configure the IP address, but IP address will be configured automatically through a SLAAC, but the other info like optional info. Remember when you do DHCP for IPv4, you must define the network ID and default gateway inside your DHCP server. There is other info like DNS server, Win server for for Windows. Okay, what else? Domain name is an optional, but it's good to have because in the real network you need to access all these service. Okay, for IPv6, all that service also can be provide their info to our client through DHCP server. But our DHCP server work as a stateless because they do not configure the IP address but configure the other info. That's a stateless DHCP server. Okay, for stateful DHCP server, they configure everything. But without DHCP server, we have a SLAAC only, which means they just only configure IP address and their gateway only. That's all. So they doesn't need to know about DNS and so on. So how a client requests an IP, get an IP. Okay, remember when we do IPv4, we do DORA. Okay, I hope you still remember what is a DORA, D-O-R-A. IPv6, we are configuring through ICMP router advertisement. Okay, ICMP is just like a ping. ICMP version 6 RA, router advertisement. A fully configured router interface with an IP address, we advertise an advertisement. Okay, I'm already configured with this IP address. So you might need to know something from me, and then you can configure by your own. That's a SLAAC, or SLAAC stands for Stateless Address Auto Configuration. For IPv6, a client will be configured based on the info provided by the router through router advertisement. So when we configure our router with the IP address and the interface has been turned up, so that interface will send ICMP version 6 router advertisement. So in this router advertisement, there are 3 info. Actually, we call as a flag. So whenever you see a flag, when you do a programming, I don't know either you do assembly programming or not before. So we are talking about flag actually just over 1 bit. 1 bit. So it's either on and off. The flag on, flag off. Okay, so in this router advertisement, they have a A flag. A stands for auto configuration. So if the A flag is turned on, which means it's set as a 1, so it means there is a SLAAC enable on this router. So you can configure your IP address automatically. But if there is a is on and O is on, O is for other configuration. With SLAAC only, you doesn't have info for other configuration like DNS, domain name, and so on. So if you like to configure DNS and domain name, you must create a DHCP server, DHCP version 6. But this DHCP server we create as a stateless without a feature to manage IP address. So they just provide the other info. So we have a A flag turn on and O flag turn on, but M flag is turned off. And we have another flag M. M stands for manage address. So if M is turned on, it will manage everything, which means we are not using a SLAAC. We must configure our IPv6 address through a DHCP version 6 server. Okay, let's go one by one. First, SLAAC 8.2 SLAAC. Not every network has access to a DHCP version 6 server, and not every network need to create a DHCP server. Sometimes it's enough for us to create the IP based on the router information only. But in this case, every device in IPv6 network need to have a global unicast address. So in order to provide IPv6 global unicast address, we can use a SLAAC method. So with a SLAAC, a client will create their own unique IPv6 global unicast address without the interaction with the DHCP server, and that IPv6 global unicast address is unique. We do not create IP that same with the other device. Actually, it's almost impossible to have the same IP. Let's see how. Okay, SLAAC is a stateless service, which means there is no server that maintain our network address information. So no need for server. Okay, the SLAAC based on the ICMP version 6 router advertisement, which is being sent for every 200 seconds. But if there is a new device has been configured to auto configure IPv6, and it cannot wait for 200 seconds. It's gonna too long. So it can request by sending router solicitation. Immediately, SLAAC will reply with the router advertisement. And then the next 200 seconds, it will send again. Okay? Which means the 200 seconds will be reset every time it receives a router solicitation from a client. So how to enable in SLAAC? As I said earlier in this slide, okay, every interface that has been configured and turned on, they will provide the info for configuring our client automatically, which means they already enable SLAAC. In order to enable SLAAC, you must do IPv6 unicast routing. I mean, in the global configuration, you must do command IPv6 space unicast routing, and then the SLAAC is enabled. So if you do show IP interface brief, IPv6 interface brief, or show IP interface for specific interface, you should see the IP address has been configured. And IPv4, we have a unicast. You have a broadcast, unicast and broadcast. But for IPv6, there is no broadcast. We only have unicast and multicast, and we most of the time use a multicast in order to do something that you do as a broadcast in IPv4. Because broadcast actually everything within that network. Multicast actually for selected group of device only. So in this case, for a router, they have a different link lock, just like a link locker, IP address. Okay. So for IPv6 all node group, they are using address FF02:1, which means this is a group for all node, which means every node, okay, it can be device, it can be a router, so everything. So they must join this group in order to receive a multicast. So whatever multicast in this group actually almost like a broadcast. Okay, so we have a link locker IP address FE80. Link locker always start with FE80. Okay, global unicast address, it must start with 2. Currently, we are using with a 2, starting with 2. And most of the time, you will see 2001 and maybe 2002. Because the IP address is so long, it can cater for so many devices. So there is no need for us to introduce 20045C and so on yet. I don't know, maybe sometime after they will introduce that to be used. But as for today, most of the time you will see starting with the 2001. Compared to IPv4, you see 10 dot something, 192.168 something, whatever number. We already use every number for IPv4. Okay, for IPv6, you see 2001. Okay, the IP DB8 ACAD column 1, and you can see /64. This is a network ID, which means the first 4 segment is fit for the network, and the last 64 bit or 64 bit or another 4 segment is a uniquely host ID, and then that uniquely host ID, it comprises of 64 bit. So if they randomly generate 64 bit of number, it might have slightly no way. It's just like no way to have the same number twice. Okay. Show IP interface. So if you have FF02, remember FF02:1 is a all node, and FF02:2 is a all router. So all router we join this group. So in here you have FF02:1, which is all node. PC also we have that group, but FF02:2 is only for router only. So PC will not join this group. So whatever multicast in this group are only for router only, not for the PC. Okay, so for SLAAC only, as I told you earlier, a flag is turned on or 1, another flag is 0. So device will get the IP automatically, which means they get the network ID from the router IP address in here, This is the network ID. Router advertise this. After that, they will generate. Okay, PC will generate the rest. I mean the other 64 bits. So in this case, they get the network ID 2001 column DB8 column ACAD column 1 from the router and generate the last 64 bit for their own IP address. Okay. Okay, for router solicitation message, it's just like a PC request, and then a router will reply BRA. I mean the same RA from previous slide. Okay. So how the PC or client or node generate their interface ID or their host ID? It's already get the first 64 bit from the router advertisement, and then it need to generate the next 64 bit. Okay, there are two ways in order to generate there. Why they put randomly generated first? Because they are the most used command or method today. They randomly generate the last 64 bit. Okay, Windows 10 are used to generate randomly. I mean, almost every operating system now generate the next 64 bit randomly. Okay, but there is other way we call as a EUI64. EUI64 they are using based on the MAC address. MAC address, if you remember, is a 48 bit of MAC address. They break down into two parts. I mean 24 bit and 24 bit. So in the middle they insert a value of FFFE. Okay. If there is a duplicate in the generated IP address, but if you still remember, MAC address should be unique. There should be no same MAC address at the same time, but maybe. So we have a method in order to duplicate them. For a random number, if you generate 64 bit of number, it's almost impossible to regenerate the same number twice, but there is a chance. So in order to prevent that, there is a mechanism to prevent them. We call as a DAD, duplicate address detection. So in order to ensure that there is no duplicate, every time a device generate the IPv6, generate the last 64 bit, they will send network solicitation message. This is a multicast containing the last 24 bit. They are not comparing everything, they just only compare the last 24 bit. If there is a change, I will change for a new IP. On 24 bit also should be random, should be unique. So they will send the last 24 bit of IPv6 address of the host. So for other device, if they compare and say the same 24 bit, so they will respond, will reply. So if they receive the reply, so a client will generate a new IP. If there is no reply, which means their IP already unique. So now we would like to have a DHCPv6 server with a SLAAC or without a SLAAC. Okay, first we take a look what is a DHCPv6. Okay, stateful DHCPv6 doesn't require a SLAAC, but stateless require a SLAAC. So in order to get the IP address, there is a process. The host send RS or the host receive RA, doesn't matter. If doesn't receive RA, they send RS first and then they receive a RA, router advertisement. And then in the RA indicate there is a DHCP server. So the host will send a DHCP solicit message. Solicit message is just like a request. And then the router, the server will respond with the advertised message. Advertise with all the info. And then the host will respond, which means so in here actually respond or also a request. Okay, solicit just intention in order to get the IP. Request, which means request to use. They accept that. and then router reply granted. Okay, so it's done. So stateless DHCP version 6 operation, which means we still need a SLAAC. So the A flag is still turned on, but DHCP server will provide with the other info. So O flag is turned on. That's all what we need to do. So how to make the O flag turn on? The A flag is by default is turned on whenever you do IPv6 unicast routing. Okay, to have O flag turn on, you need to do the command IPv6 space nd space other dash config dash flag inside the interface that you would like to advertise the DHCP or SLAAC. Remember, the interface when you configure IP, so they will advertise RA. So the interface, you also would like to advertise O, other info. So you just give this command. So if you like to remove, you just keep a no in front of that. Then if you already give this command, you need to create a DHCP server. But before that, this slide is showing you with a stateful. Stateful, which means there is no SLAAC. So we need to turn off the flag. So in the real device, you can turn off the flag. But in the packet tracer, there is no need to turn off the flag. You just enable the M. M is one. Automatically is a stateful. But in the real device, you turn M1, it's already stateful. You can also turn off flag A with no auto configuration. Okay, before we see how to configure stateless, let's compare with the stateful. Okay, stateful, just a matter of everything will be configured directly from the DHCP server. So without SLAAC. So remember, when you turn on A flag, it indicates a SLAAC. But for full managed DHCP server, you need to turn on M flag. I will show later when we do a stateful. Okay, but we can only turn on M flag in our packet tracer. In the real device, you can turn off A flag. And O flag by default is turned off. Okay, in the packet tracer, there is no need to turn off A flag because they cannot do that. Okay, so how to enable stateful DHCP version 6 on an interface? So, okay, they already show here. To enable stateful or to turn on M flag, you just need to do IPv6 and the manage config flag. Okay, for other is a other config flag. To enable O, for M is a manage config flag. For A, auto configuration config flag. So that's all. 8.4 Configure DHCP version 6 server. So before we configure the DHCP version 6 server, let's take a look what our router can do. First, we can configure as a server, I mean to provide the DHCP service, but at the same time, a router interface also can request the IP from other server, which means that interface become a client, same like IPv4. Okay, and a router interface also can be a relay agent. Okay, remember when you do IPv4, I mean DHCP version 4 for IPv4, you create DHCP server in router 1, but a device are connected to router 2. Router 2 are connected to router 1. So router 2 will be a helper. You do with the command IP helper and the IP address of the real server. But for IPv6, we do not call as a helper, we call as a relay agent. DHCP version 6 relay agent. Same like the helper. Okay, to configure a stateless DHCP version 6 server. So in order to configure a DHCP version 6 stateless server, you need to turn on O flag. So you already know how to turn on O flag. In that interface, you just need to type IPv6 space ND space the other config flag. Okay, other config flag. But now we need to create the DHCP server. because we already indicate other should be request from DHCP server, even though their IP will be configured automatically through SLAAC, but the other info. So in here, we are going to configure DNS server and domain name. So in order to create a DHCP server, same like IPv4, we create a pool. So in IPv4 or DHCP version 4, we are using IP DHCP pool. For IPv6, we are using IPv6 DHCP pool and give a name. When you press enter, you are inside sub-configuration of that pool. So here you just give the info for others only, which is DNS server, the command DNS server, and then the IP address of DNS server, domain name, domain-name, and give the domain name. That's all. And then inside that interface, let's say interface G0/0/0 are connected to the switch, then that interface need to provide the DHCP service. So we need to enter a command IPv6 DHCP server and pick a pool that you like to enable in there. So that's all. So the client will get the IP address. For a client, for a router interface, how to accept auto configuration from the DHCP server? You just need to type IPv6 address auto config, and then we will automatically configure the IP address through IPv6. Compared to IPv4, IP address and DHCP. But for DHCP version 6, in order to use a DHCP or SLAAC, we cannot put a DHCP or SLAAC. We put auto config. So that's all for configuring a client. And lastly, to configure a stateful DHCP version 6 server. So to configure a stateful, which means we need to disable auto. So to disable auto, inside the pool, you need you need to do IPv6 and it's not inside the pool. Yes, inside the pool. IPv6 and D prefix default no auto config. So they will not broadcast the auto config, which means the A is turned off, but you cannot do that in the packet tracer. So we need to do IPv6 and D manage config flag. It's not inside the pool, inside the interface. Okay. So for the pool, the command IPv6 DHCP pool name. Okay, you already know that we should put a DNS server and domain name. For the network, which means everything should be configured through the DHCP server now. So we just give the command address prefix. So it will manage the IP. And now I'm going to show you how to configure router interface with the automatic addressing by using DHCP version 6. Okay, so now when our client need to use the IP completely through DHCP, so we are using IPv6 address DHCP. Sorry, previously I told you for a client you should use IPv6 address autoconfig. Autoconfig is for stateless only, which means through a SLAAC. But if we have a full-fledged DHCP server, we should use IPv6 address DHCP. So we configure through DHCP. Okay, to verify, you can do all the show command just like IPv4. So for the pool, you can do show IPv6 DHCP pool. It will list down all the pool that we have and how many clients that we need. Because it is stateful or stateless, so we have a number of clients. Okay, show IPv6 DHCP binding. This is the link local address. They bind by a link local address. Okay, to configure a DHCP version 6 relay agent, let's say DHCP server are configured on R3. So on R1, we need to configure a relay. So where we should configure a relay? So interface that would like to provide a service. So the interface is G0/0/1. So you enter interface G0/0/1. So you need to do command IPv6 DHCP relay destination. And what is the IP address of the server? So what is the IP address server? IP address of this. Because from point of view R1, R2 maybe have multiple IP address. But the IP address that relevant to R1 is the IP address of G0/0/0. So you give the IP address G0/0/0 and follow by interface that we are going to go out, which is G0/0/0. Okay, but it doesn't say the interface of R3. Actually, this is interface of R1 that we are going to go out through G0/0/0. So that's all. So you can do show IP DHCP interface. Okay, so on the R1 you should stay as a relay mode, but the binding will be happen on R3 because the server are on the R3. So that's all for module 8. So I want you to go to the NetAcad and do all those activity. So we have a two PC, PC-A and PC-B connected through a switch, or you can ignore the switch, but the exercise wants you to redo some configuration on switch. But if you do not configure the switch, you can still get the info because there's nothing in the switch actually. So R1 and R2, you are going to configure DHCP server on R1. Okay, PCA we get the info from DHCP server in here for one stateless DHCP server, but you are going to create a stateful DHCP server for PCB. So this info will be relayed through R2. So you are going to configure a relay on this port on R2. But unfortunately, if we do with a packet tracer, we cannot do a relay. Okay, that's all for this topic. Any question?